In this lesson, you're going to learn a new formula called the distance formula, and you're going to use that to calculate the distance between two coordinate points on a coordinate grid. And then you're also going to learn the formula for finding the midpoint of a line segment, where you're finding the coordinate that's in the middle of a line segment. So first we'll talk about the distance formula. And the distance formula is based on the Pythagorean theorem, where you're finding the hypotenuse of a right triangle. So if I, real quick review of that, if I have a right triangle and I have two sides and the longest side is C, then C squared is A squared plus B squared. That's what we're going to use today. The distance formula would put a coordinate at this vertex and a coordinate at that vertex, and we would use the distance, the x distance and the y distance, and this formula to find the overall length of the line segment. So let me put that on a graph, or let's sketch a graph so we can kind of work in general terms here. Let's say I have, here's my y-axis, here's my x-axis, x, y, and let's say I have a line segment. So I have two coordinate points. We're going to label them in general terms. So we're going to say this is x1, y1, x2, y2. And I want to find the length of that line segment. Well, here's what I can do. On a Cartesian coordinate grid, you can always draw a right triangle because the x and y axes are always perpendicular to each other. So I have the same picture here as I have here, essentially. This would be my A length, this would be my B length, and we're trying to find the overall length here, which would be the C part of it. So to figure out the length here in the x direction, I got to take the difference between the two numbers. It's x2 minus x1. Same thing with the y, y2 minus y1. So if I were just to set this up, so I'm showing you where the distance formula comes from. And I'm going to label this side, well, we'll just use Pythagorean theorem. Okay, so this side would essentially, this C would be here, A would be here, B would be there. So again, I can use this up here, but I'm going to substitute in the values for this particular instance. So instead of C, I'm finding the distance. So I'm actually going to label that D. Okay, I'm using the Pythagorean theorem, but I'm putting in my own labels that I like better. So D squared, that's the length I'm looking for, that's the distance, is equal to, instead of A and A squared, it's the difference between the two x values. x2 minus x1 squared, and the same thing between the two y values, y2 minus y1 squared. Okay, but we don't write the distance formula like this because you still have to take the square root of both sides. So if we're going to use a formula, it's going to be one step and everything is solved. So the distance is big O square root, because I got to take the square root of the left-hand side, x2 minus x1 squared, y2 minus y1 squared. Okay, so that is the formula to find the distance of a line segment. So box that in. That formula we'll be using over and over and over throughout the year. So here's an example of how we're going to use that formula. Given point A is 2, -1, and B is 5, 8. I want to find this. And remember, we talked about this the other day. When I see the two letters together with no symbol across the top, that means I'm finding the length of segment AB. So when you find the length of segment AB, when you're given coordinates, you're going to use the distance formula. So here it is again. This time I'm going to say AB, because I want the distance between A and B. The formula, I'm just going to do the formula, x2 minus x1 squared, y2 minus y1 squared, and then you would take the square root. For now, since we haven't reduced radicals at all, we're just going to leave our answer. If it's not a perfect square, we're just going to leave it as a radical. If you remember how to simplify radicals, you can do that. But we're going to do that later on in the year, so don't worry about that too much right now. If I label these x1, y1, x2, y2, then I just substitute it in. That's that's the thing about a formula. It's not too, algebraically challenging. You're just writing the formula, using the correct formula, and substituting in the values. So 5 minus 2 squared, 8 minus a negative 1 squared. You have to be careful subtracting negatives, as always. Remember, add the opposite. Okay, so we have AB is equal to, I'm going to show every little step here for the first one, and that's 9 squared. You don't have to show every single step when you do it, but you do have to be careful. We'll talk about all the extra stuff in class. This is just getting the formula down for your notes here. 9 plus 81, which means the distance between A and B is radical 90. Now, you could simplify that to 3 radical 10 if you remember how. But for now, we can keep it like this because we're not doing radicals yet. So that's how you use the distance formula. And again, we'll talk more about it in class. But the thing is, you need to understand this. You need to know what this looks like and know how to use it and how to properly substitute in the values. Okay, so the second formula is called the midpoint formula. So let's define what a midpoint is. That's the coordinate, so it's a location. It's a coordinate that's in the center of a line segment, so it tells you the coordinate that is right in the middle. So to set this up, again, we have x1, y1, and x2, y2. So if I'm trying to find the middle of two numbers, you're taking the average, which means you add them together and you divide by 2. That's just what the midpoint formula is. So we denote midpoint with a capital M. Don't confuse that with lowercase m, which is slope. And again, it's a coordinate. You add up the x's, x1 plus x2 over 2, and you divide by 2. y1 plus y2 over 2. Okay, that's all you're doing. You're taking the average. So here, and I'll talk about this in class as well, this is the one formula in coordinate geometry where you are adding the coordinates. You're adding the x's, you're adding the y's. All right, in slope formula and distance formula, you're subtracting, but for the midpoint, you're taking an average, so you need to add them together. So we're going to do a couple of examples here. I'm going to show you how to calculate the midpoint, and then I'll show you a trick to, if you're given the midpoint, how to find an endpoint. Okay, here's a standard example. Find the midpoint of AB, segment AB, see there's our symbol up there, segment AB, given that A is at -1, 0, and B is at 4, 2. So, now you don't have to draw a sketch when you're doing the problem, but I'm going to just do a little sketch here to help you visualize what we're doing here. -1, 0 would be about right there on the x-axis. 4, 2 could be about there. Okay. I always recommend sketching things because it gives you an idea of roughly where that midpoint should be. So if you just eyeballed it, you would think, okay, well, my midpoint M is going to be somewhere in the first quadrant, close to the y-axis, close to the x-axis. So anyway, our formula, again, you add the x's. Whoops, I'm not writing correctly this morning. There we go. x1, x2 over 2, y1, y2 over 2, x1, y1, x2, y2. Incidentally, it does not matter which one you label x1, y1 and which one you label x2, y2. As long as, in this case, it doesn't even matter which one goes first because it's addition. So the order doesn't matter so much with the midpoint. So -1 plus 4 over 2, 0 plus 2 over 2. I'm always adding x's with x's, y's with y's. So the midpoint, let's see, that should be, looks like it's 3/2, 1.5 and 1. Okay, so that's in the first quadrant, and that kind of matches up roughly where I sketched it. Again, you don't have to draw that sketch. I just do it so you can kind of visualize what we're doing here. Okay, next example. It says given A is -1, -2, and B is 3, 1. Find the midpoint of segment AB with the symbols. And then it just says, and AB. Okay? So again, we use a lot of symbols in geometry to be more concise when we write things. All I need, because of I have 2 letters without any symbol on top, that immediately tells me I'm trying to find the length, the measure of segment AB, which would be the distance formula. Okay, so the midpoint, x1, y1, x2, y2. The midpoint is going to be -1 plus 3 over 2, -2 plus 1 over 2. Again, these formulas, just substitute it in, you crank out an answer. There's nothing complicated about it. Okay, -1 plus 3 is 2. 2 over 2 is 1. -2 plus 1 is -1, so that's -1/2. All right, your midpoint can be whole numbers, can be half numbers. That's pretty much all it's going to be, whole numbers or half numbers, if you start with whole number coordinates. If you start with decimals, it could be anything. Okay, there's the midpoint, 1 and -1/2. If I quickly sketch this guy, just so you can kind of eyeball, -1, -2 would be roughly there. There's A. 3, 1 would be roughly there. There's B. And it looks like, yeah, the midpoint could be roughly around there, so it makes sense that it's +1 and -1/2. The distance, AB, would be 3 minus a -1 squared, 1 minus a -2 squared. I did this one on purpose because of the negatives. Remember, when you're subtracting negatives, you add the opposite, and that gives me AB is equal to, that's 4 squared, so that's going to be 16. 3 squared is 9. So this one turns out pretty, radical 25. You need to know your perfect squares, because if you get a perfect square for an answer, you should be able to simplify that. So the distance between A and B is 5 units. Okay, we're going to end with a different type of midpoint problem and a different way to solve it without having to use the formula. So, got to read it carefully. B is the midpoint between A and C. I'm given A and I'm given B, and I want to find the coordinates of endpoint C. Okay, so this is what I have if I were to sketch it. Okay, if A is -4, -2, roughly there, and B is 1, 5, roughly there, well, C is going to be way up here somewhere, okay? And that's what I'm trying to find. Probably not that far, but somewhere like that. So here's what you do. You could use the formula, but I found in the past that kids really get confused trying to use the formula backwards. All you have to do is line them up, okay? You put the endpoint that you know, and then you put the midpoint. And what you're going to do is you're going to count, like, how many units do I have to get to from there to there? And you'll add the same there. And the same thing with the y's, okay? So, if I have A is at -4, -2, and B is at 1, 5, I'm trying to find C. I don't know what it is yet. Okay, so I say, well, how far do I have to go and in what direction? I start at -4, I end at 1. That means I'm adding 5. So now I want to add 5 again to the 1. That puts me at 6. And that's my C coordinate in the x direction. We do the same thing on the other side. From -2 to 5, I'm going +7. So you go another +7. 5 plus 7 is 12. Okay, so C is at 612. And if you look at the picture, it kind of makes sense that C would be up there somewhere. Okay, so we will talk more in more detail in class, but that's a basic introduction of the distance and midpoint formulas.